Okay, so we set this up right here, and we hope that, I think, kids, my best guess is it's 12. I'm pretty sure it's 12. What do we have to do at this point? We have no choice but to do what? We have to do algebra at this point, right? One thing that's nice is that you see this 3 over n. We're only moving the I value, so what can you do with that 3 over n to begin with? You can do it out. It doesn't really change much, but on these, my recommendation is break them down into as small pieces as you possibly can. If you break them down, I think, for me personally, it's much less likely you will make an error if you break it down into smaller pieces. That's just my thought. Really easy errors are the ones that will sink you here. So at this point, what should you do to that summation? What should you turn the summation into? You have one summation. How many should you turn it into? Turn it into 2 summations. So you have the summation of I equals 1 to n of 9i squared over n squared plus what? The summation of I equals 1 to n of 1. Can someone tell me what this right here, what does this come out to be? No, it's 1 plus 1 plus 1 plus dot 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 all the way to how many times? There are n of them. So what does this equal? 1 to the n? 1 plus 1 plus 1 8 times is what? 1 plus 1 plus 1 n times is what? N. This equals n right there. Okay, on this summation right here, is there something you can factor out of this second summation? What can I put in front of this summation right here? You're only moving I, so what can I bring out to the outside? 9 over n squared times the summation of I equals 1 to n of what? I squared plus n. What's the summation of I squared? You know what that is, right? Yeah, you have to. This is really important. You must memorize that. It's not a negotiable. You have to do 9 over n squared times, in oh, nope, the parentheses was right here. That's important. Times what? N times 2n plus 1 all over what? 6 plus what? N. Now, we've gotten rid of all the sigma notation. Now what can we do? What do we still have to do at this point? Now it's really just algebra. At this point, it's just algebra, and then you're going to do the limit. And theoretically, could you explain the concept of this type of limit, theoretically, to maybe an Algebra 2 student? Like, what's really big over really big? It's not it's not totally out there anymore. I also firmly believe you can teach calculus to younger kids. So what do we have to do at this point? We really just have to do what? Algebra. So we have, how many terms do we have here? Remember that we have this 3n floating on the outside. So what do we have here? We have the limit as n goes to infinity of, let's multiply this in. We have 3 over n times 9 over n squared times what? Now, what are we only really interested in this fraction right here? Not the leading, yeah, we are interested in the leading coefficient, but we want the highest powered term, right? So what is this going to be? 2n to the what? Plus whatever, right? Do you understand why that's okay? It's all over what? 6 plus, there's another limit here. I'm doing 2 limits here. So limit of n go to infinity of 3 over n times what? Times what? Times n, yeah. Now, which one's really nice to do? This one, because what cancels? What's the limit as n goes to infinity of 3? It's just what? It's just 3. Are we okay with that? Yeah? Okay, so what does this become? This becomes the limit as n goes to infinity of 3 times 9 times 2 times n cubed all over what? 6n cubed. And there's still plus something here, right? Do we really care? We don't. This is plus 3. Okay, that's nice. So what do we have here? This is going to be 3 times 9 times 2 all over 6 plus 3. So what's that going to be? It's going to be, this cancels with this. It makes it a 2. This cancels with this, and you end up with 9 plus 3 is 12. 9 plus 3 is 12. When we're looking at this one right here, can someone just tell me what that means? I'll start you off. That means the area under the curve. What's the curve in this case?
1 plus 3.
1 plus, so this is the area under 1 plus 3x from what to what?
Negative 1 to 5.
From negative 1 to 5. What's nice about this function in particular? It's
Linear.
It's linear. So should the algebra be relatively better than what we've done before?
Yeah.
Yeah. So how do we write this? They want you to write this as a limit. It's the limit as n goes to infinity of what? The summation of I equals 1 to n. What's the width in this case? What's the width? So it's going to be 6 over n, right? times 1 plus 3 times what? It's 3 times this thing, right? What goes in there, that blank? That's the trick right here. What are you starting at? What's your starting value? Negative 1 plus what? Plus 5? No. Remember, you're adding the pieces to it. It's that thing in terms of I. 6I over n. Where did 6n come from? 6 over n is just the width of each piece, right? So every time you move over 1, I is just incrementing by 1. Is this a lot better than what we just did? This is a lot better than what we just did. So what do we do to set this up? Well, just you can limit as n goes to infinity. What can you factor out? 6 over n, and then it turns into two summations, right? Summation of I equals 1 to n of what? 1, right? Plus 3 times the summation of I equals 1 to n of negative 1 plus 6i over n, like that. You can factor out the 3 because does this 3 have anything to do with I? Like, as I changes, does 3 change? No. So what does that first term become? What does this term become right here? Becomes what? N, yeah. So it turns into the limit as n goes to infinity of 6 over n times what? N plus 3 times, now how many summations do we have here? 1 to n of negative 1 plus 6 over n times the summation of I equals 1 to n of I. What's this one? What's the middle one right here? What's that come out to be? Not 3n, you're close. Negative 3n. You can factor out that negative. So it turns into 6 over n times n minus what? 3n plus 6 over n times what? Yeah, what does this mean right here? What does that mean? That's 1 plus 2 plus 3 all the way to what? Plus n, right? And what do we know that equals? N times n plus 1 all over 2. So now can we distribute? Yep. We end up with the limit as n goes to infinity of what? 6 minus, what's 6 over n times 3n? 6 over n times negative 3n, what's that turned into? The n's cancel, and what are you left with? Minus 18 plus 36 over n squared times n squared plus n over 2. What's the overall power? What's the power of the top right there? What's the power? Squared. And what's the power of the denominator? Is that a good thing? Yeah, that's absolutely a good thing, because if they weren't, what would be the problem? You'd either be getting 0 or it'd be bad. So what do you hear? Negative 12 plus 36n squared plus 36 all over, n over 2n squared. So what does that limit equal? Negative 12 plus equals 6. It equals 6. Seems like a lot of work to get a single answer, don't you think?
Yeah, what's the easier way?
What's the easier way? We made one small thing, so what's the problem? This right here should be multiplied by 3. So this should be 18, right? So this should be 3 times 36. There should be a 3 right here. So this should be times what? Times 3. So what does that turn out to be? Negative 12 plus 30, 54, which is equal to 42. That is correct right there. 6 was too small. 42 is correct. 42 is correct. So look what we did there. We made one simple algebra mistake, and it cascades down. It's challenging. It's really challenging. In this case, what's the shape? Can anybody tell me what this shape looks like? Yeah, but what's the shape of this area look like? What is this called? It's the area under a line. What's that shape going to be called? Trapezoid. It's going to be called a triangle?
Oh, I just think it's like the origin.
No, you're going to have the function y equals 1 plus 3x, and and then you have y equals 0 right here, right? So what does this area look like? It goes from negative 1 all the way to 5. This is the area you're looking at. That's what it looks like right there. That's what you just did. That's what you just did. Of integration. If you have numeric limits of integration, you have a definite integral. So what we're going to look at later, indefinite integrals, they won't have those limits. What does that mean? Okay, but we're not quite there yet. So what this looks like visually is, let's say f of t is some function right here. So that right there is this is f of t right here. F of t, they're like the little hook right there. Here's our a value right here. This is x equals a. So what g of x is the area under the curve from, let's say this right here is x. So this area would be g evaluated at whatever that x value is. And then as this moves over, what happens to the overall value of g of x? It increases. As I move this barrier, the green barrier over, what happens to the overall area? It increases. What happens if I move it towards that value? It decreases, right? It decreases. So all this is saying, that's the definition so far. So f has to be continuous on that closed interval. So this function, f of t, has to be, you can write it without picking up your pencil. Then this is the important part right here. If all of that is true, so if it is continuous on the closed, it tells you that g of x is continuous, meaning if f of t is continuous, the area as it increases, can you ever jump over a certain area here? No. If the boundary is continuous, the area under the curve has to be continuous. But the big important for FTC part 1, fundamental theorem of calculus part 1, is right here. So I just said that g is continuous and the derivative of g of x is f of x. The derivative of g of x is f of x. What this tells you is the following. The derivative of an integral of a function is the what? Think about it this way. If you're at a function and you anti-differentiate it, you get to the integral. So if you're at acceleration and you integrate, what do you get to? Velocity. But if you differentiate velocity, where are you? You're back at acceleration. So what does this basically tell you? It tells you that differentiating undoes what? Integrating. If you're at a function and you integrate, you go up to the integral. And if you take the derivative, where do you end up back at? The function. So if you're at velocity and you integrate, where are you? Position. And if you differentiate position, where are you? Back at velocity. So the fundamental theorem of calculus part 1 essentially tells you the derivative of an integral of a function is the function. So done out, this is what it could mean. Let's say g of x was equal to the integral from a to x of f of t dt. What this means is if you take the derivative of both sides, the derivative of g of x is g prime of x. What is this telling you? F of t is the boundary of the volume. The derivative of g of x is going to be what? F of, not f of t, it's f of x. It's okay if this doesn't make total sense right now. You just have to remember this. The derivative of an integral is the function itself. And in this case, the function itself is not f of t, it's f of x. You can't have t here and here. Just remember that for now. You'll be more comfortable believing that later, but it's really important that you understand this right now. This represents, right here, how do you say this? The area under f of x, under the curve f of x, from what to what? From a to b. So what is this telling you? We had something else before. What did we have? We had the limit as n goes to infinity of the summation of I equals 1 to n of f of x sub I star times delta x. That was the Riemann sum, right? Did you like doing that algebra? No. What does this tell you? If f is continuous on a to b, then the integral, the area under the curve from a to b, is equal to capital F of b minus capital F of a, where capital F is any antiderivative of f that is a function such that the derivative of f prime is f. Does this click yet in your head? Because it will in about 10 seconds. You ready? What does this fundamental theorem of calculus part 2 tell you? It tells you that this is equal to, what's the integral of 1 plus 3x? If you anti-differentiate 1 plus 3x, x plus 3 over 2 plus what? Plus c. This tells you that the integral there is equal to this right here. I'm going to write this a little differently. This right here is equal to, this is f of x. So this is f of, what's the upper value? 5 minus f of negative 1. So what is f of 5 in this case? 5 plus what? 3 over 2 times plus c. And what's f of negative 1? Negative 1, oh, don't close it, plus what? 3 over 2 times negative 1 squared plus. So what does this equal? 5 plus 75 over what? 2. And what does this equal? Negative 1 plus what? Which equals A half, right?
You can just get rid of the C.
5. Oh, yeah. What? The C's. Why am I kind of ignoring the C at this point?
Because you're subtracting.
You're subtracting C from C. In every single instance, you're going to be subtracting C. Because you have to use... So you guess what you never are going to write from this day forward when you're integrating. Unless it asks you for the general antiderivative. So what do we end up with? 5 plus 75 over 2 minus what? Minus 1/2, right? So what's that equal? 5 plus 74 over 2. Is that correct? So that's 5 plus 30, which is equal to what? Oh no. Oh. It was the integral from what to what? Negative 2 to 1 of what? X plus 2 squared plus 1, I think. Was that it? Can you guys check that for me? Before we integrate, let's multiply this out. What is x plus 2 squared? Plus 4x plus 4 plus what? 1 dx. So what does this equal? Negative 2 to 1 of x squared plus 4x plus what? 5 dx. Because that's the width. Remember, this is the height of each rectangle. What's the dx? The width of each rectangle that you're adding together. Now, what's the integral of each of these, of that function? It's going to be 1 over 3x cubed plus 2x squared plus, and technically what do I have to put in here? Plus c. I'm just putting it there because this is the very beginning. And the way you're going to write this is you put a bar and you evaluate. This means you're evaluating from the upper one is 1 and the lower one is negative 1. This bar with these numbers means evaluate. So plug in 1 and what do you get? 1/3 plus 2 plus 5 plus c minus negative 8 over 3 plus what? 8 minus 10 plus c. What automatically cancels, Biggie, that you pointed out? Yeah, c's cancel. Is that going to happen every single time you do this? Are you going to write in those c's? Not in this case, but I'm putting it there so you know what the c, what happens to it? It cancels, exactly. So what do we end up with? We end up with 1/3 plus 7 minus what? Negative 8. Oh, we'll just do this out. Plus what? Plus 8 over 3 plus 2, right? Because you're subtracting negative 2.
Yeah.
Is that correct? So we'd end up with 9 plus 9 over 3, which is 12. Was that a little easier than what we just did? Was that a little easier?
Yep.
Super challenging one?
Is capital F always the antiderivative?
Generally speaking, but not always. They're going to say it specifically. If they use capital F, they usually say it is equal to, like, they'll define it some other way. They will say it specifically. It is very common for capital F to be the antiderivative of lowercase f. Is that always going to be the case? No. Usually they'll say f and f prime is what they will say. So how about you do this? The integral from, how about, let's go from 2 to 6 of x plus 1 squared minus e to the x. Do that for me. Tell me what that is equal to. Do that out. It could be. Yeah. Let's take a look. I'll show you. I'll show you. Okay. So 2 to 6. You have to do it out, right? 2x plus 2 minus e to the x. Is that what it come out to be? Is that it right there? What do you think? Is that it? No, I'm not done yet. Oh, plus 1. Thank you. Oh, plus 1. Okay. Are we okay there?
Yeah.
Okay, so now what do we need to do? We need to, what's it called? Anti-differentiate plus x squared plus x minus what? Yeah, because what's the derivative of e to the x? Yeah, and this is going from what to what? 2 to what? 6. So yeah, it gets a little bit nasty, but would this be a lot worse if you tried to do it using the method we did before? Yeah, so what does it come out to be? 1/3 times 6 cubed plus 36 plus 6 minus e to the 6th minus 1/3 times plus 2 minus e squared. So what do you end up with? 216, right? Over 3 plus 42 minus e to the 6th minus what? 8 over 3 plus minus e squared. Is that correct? Yeah, that's nice. So what does this come out to be? E to the squared? Oh, plus, right? Plus e squared, we decided. Minus what? E to the... Yeah, e to the 6th. Is that a big or a small number? So I end up with this. I end up with negative 290 point what? 706 to 3 decimal places. Who got that? So the question is, first of all, do you believe that that's the correct answer? That this is what it's giving you? Yeah, you are totally correct. So the question now is, well, two things. One, could you have done this without your calculator? Meaning, sorry, could you have integrated this? Could you have gotten to here? Could you have gotten to this point without this fundamental theorem of calculus part 2? Not really. I mean, you don't know what the summation of e to the x is, do you? You'd have e to the first plus e to the second plus e to the third plus e to the fourth plus e to somewhere in there, right? This allowed you to integrate something that you wouldn't have been able to do before. And then the second question is, why do you think the answer is negative, Biggie?
Because it goes below the...
Yeah, let's see what this looks like. So what does this function do? It goes up a little bit, and then it goes down. So when you go about finding the area under this curve, you're actually not finding, area is not the best way to say it. We say it that way because we look at positive things above the x-axis first. So from here, from right there, there is a little bit of, quote, positive what? Positive area, right? But then what happens? You're going all the way to 6, right? What do you have here? What would you call this? Like what you would call that, quote unquote? Is it really negative area? No. What you're talking about is net change. Net change.
So it's from...
The integral net change. It gives you the net change. So if it goes below, it will kick out a negative value. So no, you can't just make this positive, right? Because if you just make it positive, look, it counted this part as positive and this part as negative, and it added them together, right? If you wanted to, this is something we're not getting to yet, if you wanted to know the overall area here, you would have to find this area right here, and then you would have to find this area. But what would you have to do to this one? You have to make it positive, and you have to add these two together. Is that what you're doing right now? No. This is positive. So let's just say make up numbers. Let's say this was 6 and this was 100, right? What's 6 minus 100? Negative what? Negative 94, right? So if we integrated it, if this was 6 and this was 100, this would be altogether negative 94, right? Is the overall area 94? No, it's 6 plus 100, which is, we'll do that later, but you have to find that point, you have to integrate. So what happens, instead of going to 6, let's say I made it go to here. Let's say I made it go to there.
It could be 0.
It could be 0 if we put it close enough to make this equal to that, right? You're absolutely right. That would be a cool question. Like, where would I have to place it to make this integral equal to 0? But let's pull it in a little bit. Let's pull it in right here. So let's pull it into, what was this? 6, 5, 4. Let's pull it into 4. If we pull it into 4, let me show you a neat trick here on your calculator. You can watch this. Watch this. If we math, it's going to look different on your calculator, but I just want to show you a preview of what's to come. Function int. What did we went from? What did we say? From what to what? What was our starting value? From 2. Oh, we started at 2?
Yeah.
So ready? Well, let's go from 2 to 6. Let's just see what it comes out to.
Yeah, we just did this.
I know. But let's just do it on the calculator instead. What was it? It was x. We got to do it out in this case. X to the 2 plus what? 2x plus 1 minus what? Second, where's e? E to the what? X. And it's dx, right? Yeah. Press enter. What does it come out to be? Oh, that's pretty cool, isn't it? Pretty neat. So here's the only reason I tell you this now is I want to emphasize something. On the AP test, what is your most valuable asset? Calculator. And time. Not calculator. What are you walking me into here? Your most valuable asset is time, right? So if on a calculator section, you're supposed to evaluate this integral, what is it totally okay for you to do? Use your calculator, right? So what do I see people? Should you use a Riemann sum if you have your calculator? No. Should you do out the integral by hand if you have your calculator? No. If you have your calculator, what should you do? Use your calculator, right? We'll talk about this a little later because we have to do it a little bit more by hand because 60% of the test you do not have your calculator. So why is that? Because you just did this square and that square. You can highlight it a little differently. So that's g of 1 right there. What about g of 2? It's 2, then 3, then 4, then... Well, no, that's half of 2 of them. So what is it? 5. Because you have 1, 2, 3, 4, and then you have a triangle that's 1/2 base times height. You're assuming it's a line, right? So what is it? 5. What's g of 3 going to be equal to? Yeah, what are you adding to it? You're adding half of base times height here, so you're adding 2 of them. So what's that equal to? 7. Okay, so that right there, keep in mind, that's 1, this is 2, this is 3, 4, 5, and 6. So in your head, do this in your head, come up with g of 6. So when you take g of 6, it goes all the way to here. The green, it has to be negative, right? Because it's below. So what is this? That is equal to 4. So you have 7 minus 4, which is 3. So this one is 3. So what happened there? From 0 all the way to 3, what's happening to the g values? They are going. So on what interval is g increasing? On what interval? 0 to what? 0 to 3, right? Because from 0 to 3, you're always adding area, right? Because it's always, this function is always above. But then what happens? It goes below, so then where's it decreasing?
3 to 7.
So here's a question for you. Where do you think g has a maximum value? At t equals what?
3.
At t equals, so let's write this in from 0 to 3. At t equals what? 3. And what's the output value? Like what's g of t going to be at that point? G of 3 is what? We already know what it is. G of 3 is 7, exactly. So now it says, sketch a rough graph. How would you sketch a rough graph? Literally, what would you just plot? The points. You would plot the points there. So we could actually do this right here. What do you think the derivative in this case is going to be? 1 plus 2 times what? X squared times what? 2x. Because what do you have to use? Yeah, what's actually invisible on the outside of all of these? 1. Because what's the derivative of x? 1. 1. But here, if you change the limit, what does it go to? You have to do the derivative. You have to use the chain rule. Exactly. So sometimes you have to remember the chain rule. Yeah. There's 2 other identities that are really, really important. Kids, big E, more important than what you're doing right now. The integral of a to b of f of x dx is equal to, what happens, do you think, if you flip these? It becomes what? Negative. That right there, huge. If you flip, don't move, it's huge. This is the last one I want to give you. If you do the integral from a to c of f of x dx, that's equal to the integral from a to b of f of x dx plus what? Integral from b to c of f of x dx. You will need that tonight. Homework will be in your notes.